For our next problem, we'll solve a radical equation. We have the square root of x minus 3 plus 5 is equal to x. The first step in solving a radical equation is to isolate the radical. So we'll subtract 5 from both sides of this equation, and we'll have the square root of x minus 3 is equal to x minus 5. Next, we'll raise both sides of this equation to the second power since we have a square root. On the left-hand side, the square root of x minus 3, that quantity squared, just gives us x minus 3, is equal to, on the right-hand side, remember when we square this binomial, x minus 5, we end up with a trinomial, x squared minus 10x plus 25. You can just simply write out the x minus 5 times x minus 5 if you like to get that right-hand side. Now we have a quadratic equation that we need to solve. Let's put all of our terms on the right-hand side and set the left-hand side equal to 0. So when we do that, we'll have 0 equals x squared. Notice we're going to subtract x from both sides of this equation. The right-hand side has negative 10x. When we subtract x from both sides, we get minus 11x. And as far as our constant terms, we already have 25 on the right-hand side. When we add 3 to both sides, we get plus 28. Now this looks nice on the right-hand side because we can factor this. And we'll have 0 equals, let's set up our parentheses with an x and an x. It looks like we need two negative numbers to multiply together to give us positive 28, but we want those two negative numbers to add up to negative 11. It looks like negative 7 and negative 4 will work. It's always a good idea to check your factorization. So now we'll apply the zero product principle, setting each factor equal to 0. We have x minus 7 is equal to 0, or x minus 4 is equal to 0. So we have two potential solutions here. First, we have x is equal to 7, and next we have x is equal to 4. I use the word potential solutions because we need to check both solutions in our original equation. Remember, anytime you raise both sides of a radical equation to an even power, it's possible that you'll come up with an extraneous solution. So we need to check both of these. First, we're going to check x equals 7. We'll substitute 7 in for x in the original equation. So we'll have the square root of 7 minus 3 plus 5, and since I'm checking, I'm going to put a question mark above the equal sign. Is that equal to x, which we're substituting 7 for x? So the square root of 7 minus 3 is the square root of 4 plus 5. Is that equal to 7? What do we have? 2 plus 5 is equal to 7. Sure, that checks. So x equals 7 is one of the solutions. Now let's check x equals 4. We'll substitute 4 in for x in the original equation. Is the square root of 4 minus 3 plus 5 equal to x, which we're substituting 4? So the square root of 4 minus 3 is the square root of 1 plus 5. Is that equal to 4? Well, the square root of 1 is 1. 1 plus 5 is not equal to 4. So therefore, x equals 4 is an extraneous solution, so we can cross that off from our potential solutions. And it's important to note that here. X equals 4 is extraneous, so it's not part of the solution set. The solution set is the set containing 7.